So guys, yesterday we were talking about sinusoidal functions. I'm just going to kind of go back and quickly talk about them. We looked at angles. We reminded ourselves that angles could be in radian mode. Okay, there were 2 pi or 6.28 radians in a circle, and we switched modes. Keep in mind you push mode button on your calculator. The third or fourth option down is in radians. Then we talked about periodic and sinusoidal functions. A periodic function repeats the same pattern. Sinusoidal function does the same thing, but it's also more rounded. Okay, there are lots of examples of sinusoidal functions. We talked about sunrise, sunset time. This is can. Fix it now. Okay, can be modeled. There's sunrise, sunset time, Ferris wheels, water wheels, electricity, pendulums, phases of the moon, etc. All sorts of things. The thing about any sinusoidal function is it has these 3 things: a median value, an amplitude, and a period. The median is exactly halfway between the max and the min. The amplitude is the distance from the median to the top or the median to the bottom. The middle to the max or the middle to the min. Okay, and it's always the same. If you've done the median right, you've got the amplitude. It'll always be the same. People at the other class asked me, what if it's changing? Like what if it's 8 one and then 7 the next and then 14 the next time? If it's changing, it's not a sinusoidal function. It's just not. Okay, so that's what happens there. Period, though, is the length of time it takes or the distance required for it to repeat. So then we looked at a question like this. Given the graph below, identify the amplitude, median value, max, min, the length of the period. We did this on the smartboard, but keep in mind that the maximum's 20. The minimum's -10. Okay, the median is exactly halfway between 20 and -10. If I add them together and divide by 2, I'm going to get my median value is 5. Okay, from there I start talking about my amplitude. Well, my amplitude is the distance from the median to the top or the median to the bottom. If the median is 5, it's 15 up to the max, or it's 15 down to the min. The amplitude is 15. Okay. From there, then we looked at the period. Now, to find the period, you have to pick 2 points that are exactly the same. So we picked, I think, this one and that one, the 2 top points. And how far apart are they? And they are 15 apart. Or you could pick the 2 bottom points, 7.5 and 22.5, and they are 15 apart. Or you could pick some point somewhere in the middle if you knew it. And if you knew that, you just need the next time it's at the same point, same height, going the same direction. And the next time is where that black dot is. Those are both at that level, going up, going in the same direction. And if I knew those points, they would be 15 apart. What if it changed is a question the other class asked for this one as well. If it changes, it's not sinusoidal. It's something else. So if it's a sinusoidal function, it'll always be the same. So the period is 15. You guys yesterday asked, are the amplitude and period always the same? No, it was just coincidence. So you looked at this next question. Here we did this one. Okay? And the median was 1, the maximum was 5, the minimum was -3. It was 4 from the middle to the max, or 4 from the middle to the min. So the amplitude is 4, period was 10. We looked at that. Then we went through and we did some of the theory. Keep in mind it's going to have a form of a times the sine of bx plus c plus d. Okay? And the amplitude's the a value. The median is the d value. The period is 2 pi divided by b. That is the only piece that's given to you on the formula sheet. The rest of it you have to memorize. The maximum is the d value plus the a. Minimum is the d value minus the a. Y-intercept, you let x equal 0, plug it in. Type it into your calculator. Provided you're in the right mode, it'll give you the y-intercept. X-intercepts you're going to do graphically. We're not looking at it algebraically. That's part of Math 30-1 and Math 31. But for you guys, you're going to do it graphically. Keeping in mind that if there are any x-intercepts, there is an infinite number of them. So it has to give you a lower edge and an upper edge to consider. Because really, there's an infinite number of them. And so you can't list them. And we don't talk about what's called the general solution. So you can't list them. So when we're looking for x-intercepts, we're just looking for the x-intercepts between such and such and such and such. Okay? Now we did this example here. This is where we kind of stopped. Determine the amplitude, the median, the midline, the period, the max, the min, the y-intercept, and the x-intercepts from -10 to 10. And so we did that, keeping in mind the a value was 5, the b value was 3, the c value was 2, the d value was 1. We got all these pieces. I let x equal 0 here, and that gave me the y-intercept. When it came to the x-intercepts, we counted them. There were 19. So we didn't do it. But we let y2 equal 0, and we discussed how we could do it. Okay? Going on with this, what I want to do, my last example is example 2. Okay? And I just quickly want to talk about it. And so, as such, my last example, I want the same things, the amplitude, the max, the min, the median, the midline, all that jazz. Y equals -3 times the sine of 1/2 x plus 2 plus 1. Okay? And I want it for these ones. Now, I've got this example for 2 reasons. One, it's got a negative a value. The negative is doing something called a reflection in the x-axis. Because it's negative, you would just ignore the negative. You don't worry about it. The amplitude of this is 3, because it's going to go 3 up and 3 down. Really what it's going is -3 up and -3 down, but it still ends up being 3 up and 3 down. So the amplitude is still 3. So the notes that I gave you where the amplitude is the a value, that's really how we think about it, but really whatever the a value is, you just take the number part. Okay? So the amplitude is 3. The median, based on the data, it's the d value, it's the 1 that's right there, so it's +1. Okay? To find the midline, just because it ties into this, keep in mind, midline has to be the equation of the horizontal line that's in the middle. So the equation of that line is y equals +1. It's exactly the same number as the median, just you have to have the y equals, because without the y equals, it's not the equation of a line, it's just a number. So it doesn't actually work. The maximum value. The maximum value is the d value plus the a value. The d value is 1, the a value is 3, or the amplitude is 3, so it's the maximum is 4. The minimum is the d minus the a value. D is 1, amplitude is 3, 1, I don't know why I said +3 again. 1 minus 3, -2. That's the minimum value. So the amplitude, the median, the midline, the max, and the min. I've done those. Is everybody okay with how I got those? Questions, if there are any. Continuing on with this, I'm going to do the period. Now the period is the other reason I put this in. The negative on the a was one of the reasons. The period is the other reason. Because the period is 2 pi divided by b. b is 1/2. If it's a fraction, you have to put it in that way. You have to put the brackets around it. It's 2 pi divided by 1/2. You could say 2 pi divided by 0.5 if you wanted to. If you do it as a fraction, going to the calculator, I have to type, you can see it right there, 2 pi divided by 1/2. Okay, right here. 2 pi divided by, bracket, 1 divided by 2. Do you see that up here? It's in this spot right here. 2 pi divided by 1/2. And so the period is the 12.5637 da 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 da. Does that make sense? So the period becomes 12.657. So 12, what was it? 12.65, does anybody remember? 12.56? So the period is 12.56, approximately, okay? In Math-1, we talk about it in terms of fractions of pi. So we talk about exact values. You guys don't need that. 12.56 approximately is what the period is. Now, going from there, That's those first ones. Period tends to cause the most confusion because people think, oh, it's the b value, but it's not. Okay, it concerns the b value, but you have to plug it into the formula. Amplitude is the a. Okay, now the next things I need are the y-intercepts. To find the y-intercept, I go into my calculator and I let x equal 0. So y equals -3 times the sine of 1/2 times 0 plus 2, close the bracket, plus 1. And I've got to type that into my calculator. If I do it right, if I'm in radian mode, it'll give me the y-intercept. And the y-intercept should always be between the max and the min. Should always. Because if that's the max, that's the min, then it has to be between them. So I go to my calculator, and I say it's -3 times the sine of 1/2 times 0. Okay, was it plus 1? I can't remember now what it was. Plus 2, and then plus 1 outside. So plus 2, and then close the bracket, and then the plus 1. If I'm in radian mode, it'll find it for me. I just do it, boom, there we go. -1.72 is the y-intercept. Okay, approximately, -1.73 actually. Okay, so y is approximately -1.73. Okay? It may work out nicely, it may not. For the x-intercepts, this one I'm going to do. For the x-intercepts, okay, what you're going to do is you're going to go to your calculator again. You're going to push y equals, clear out whatever's there, and you're going to sketch it. -3 times the sine of 1/2 x plus 2 plus 1. Okay? And you're going to sketch y2 equals 0. I already had that. I left it. Now keep in mind, for the x-intercepts, it wants the x-intercepts between something and something else. So I push window, and my question, this is the one we were working on yesterday, it's from -10 to 10. So I put those in for my x's. Now, in all honesty, the y's don't matter. I could put the max and the min for the y max and the y min. That would zoom in on it as best as possible. You don't really need it, but I'm going to kind of say, okay, the maximum, what was the maximum of our equation? Do you guys remember? What was it? Not the maximum, the minimum is -2. -2 is the min, 4 is the max. So I could put that in and then I graph, okay? Error window range, what did I do? Oh, I think I know what I did. The min is -2. I put them in the wrong spot. So the min is -2. The maximum's 4. The calculator just got confused. So I hit graph. I take a look at this. So there's the graph of my sinusoidal function. And I've got to find all the x-intercepts that show up on this window. There are 3. One of them's here, where the finger's pointing. One of them's here, where the finger's pointing there. And one of them's there. And you just have to do it 3 times, trying to find the intersection point. Second trace, choose option 5 for intersect. First curve, second curve, and guess. Pick one to do first, put the guess close to it, because keep in mind it's going to find the one that's closest to the guess. That's about where it is. There's my guess, hit enter, it finds it. The first x-intercept is -3.32-ish. So I go back to my calculator, okay, so one x-intercept is x equals -3.32. There are 2 more, so I'm going to list them, and I just go back in my calculator, do it again. Second trace, intersect. First curve enter, second curve enter, guess. I'm going to move the guess over to the next one. Okay. And it's about there. Hit enter. The next x-intercept is 1.6035, so 1.60. So that's my next one, so go back over here. +1.60. And last but certainly not least, I do the third one. So go into the calculator, second trace, choose the intersection, first curve enter, second curve enter, guess, I'm going to put it over here at this one, and it just takes a while, but you just do it. Okay, in fact yours probably is a little more responsive than mine. Hit enter, and the third x-intercept is 9.246 or 9.25 approximately. So I go to mine, and then it's 9.25 approximately. That's the x-intercepts. It may be a nice whole number, it may not be a nice whole number. Okay, but that's how you do this. Does this make sense? Sinusoidal functions. Your purpose for today is to do your homework. Basic homework is page 506 and page 528. Mastery homework is a little bit more. So there's your homework. I'm going to leave it up on the screen for you guys to work on. You've got the remainder of this block to work on it. I am not going to take up this homework until after the break. Okay? Tomorrow the plan is we're going to review for the polynomial functions test. Okay? So there you go.